From 1800, 180 plus years passed free from any flooding in Stonehaven caused by the Carron burn. One of the oldest buildings in Stonehaven was the meal mill, which was situated in the area of the car wash facility now behind the BP filling station in Dunnottar Avenue. This mill dates back to the late 1700s, and the next building to be built in this area of the town was the Mill Inn, taking its name from the closely adjacent historic meal mill. All early mills were driven by water power, and therefore a suitable water supply had to be constructed. Obviously the Carron would be the water source. A laid channel was dug and lined with dry stone walling from the mill to a point where it could open into the burn. At the same time, 2 further lathes were dug, and again dry stone lined from mill to the return of the used water to the burn further downstream. The earlier earthen weir was built to ensure that a water supply was always available. The early map from 1824 shows the first weir along with the roots of the lathes and the discharge point into the burn near the beach. As time went on, the mill became bigger and it needed a better water supply. With this in view, a mill dam was built, and the original weir had to be rebuilt at a higher level to ensure that it could deliver water into the new dam, which had been built at this higher level to give the miller more gravity-created water speed for his mill. In this map of 1857 you can see all the details of the weir with the dam and the mill lathes, only by this time the discharge lathes were passing through several underground sections on their way to the discharge point in the lower river. As in the first map, it clearly shows the position of the island, which lies just under the edge of the weir construction on the spillway side of the weir. This island is obviously a long way below the spill point level on the weir, and therefore in no way affecting the flow of the river. This weir was built 50 yards long, and stretched from where the Green Bridge would eventually be built, downstream to a point just a few yards beyond where the Glaslaw burn entered the Carron. Weirs have been used all over Europe for centuries to divert water for powering industry. Also, they were vital in maintaining water levels in rivers and, more importantly, in canal systems to allow navigation by barges and watercraft. Finally, they were extensively used to prevent flooding in areas upstream of any weir. The water level in most major navigable rivers was controlled by the use of weirs. Notice how little height to overspill point there is on the river banks opposite the weirs, simply because the river level cannot rise here to cause any problems because of the efficiency of the weir. In the case of the Carron, it was observed over approximately a 30-year period that the water above the 50-yard weir never rose more than about 6 inches in any of the regular big spates on the river. As a result of this knowledge, it was decided to build a green bridge across the river at this point. From the time this bridge was built, up until the weir was deliberately destroyed and removed by local government, there was never a single occasion when the waters in the flood reached within 2 feet of the overspill point at this site. I personally was there in the 1948 major flood, which finally broke through the shingle banks on the beach and created separate river mouths for the Cowie and Carron. In these old pictures you can see what it looked like looking upstream from the Green Bridge when the weir was in place. At first glance it's remarkably similar to what you see today. The difference is that as far upstream as the red marker in the photograph, the water was at least 3 feet 6 inches deep instead of the few inches we have today. In the second picture you can see how little clearance there was between the water level set by the spillway and the underside of the bridge, but because of the efficiency of the 50-yard weir, the water level in the 1948 flood only rose about 6 inches, causing absolutely no hazard at all. Over a century and a half had suffered an amount of erosion to the spillway on the downstream side of the weir. The concrete top of the weir was still totally intact. It would only have required a load of rough concrete and a few days of pointing to restore the weir to be in good condition for another couple of 100 years, saving Stonehaven and particularly the Altoon from the risk of any flooding originating from this location. Nevertheless, the decision was made to demolish this long-proven flood-preventing weir and replace it with what I can only describe as a photogenic water feature. In early January 2013, I wrote to Sir Robert Smith MP with a list of questions which can be found on the website. One of the questions I asked was any risk assessment ever carried out as to what effect the destruction of the original weir would have on flood prevention? Also, what were the qualifications or experience of any of the person carrying out any assessment? The response I received on the 28th of January from Aberdeenshire Council Infrastructure Services regarding this question was: there have been many changes to staff dealing with flood-related matters over recent years, and various elements of work which Mr MacDonald questions predated those staff working in the Council. It can, however, be safely assumed that those involved would have been appropriately experienced practicing civil engineers, or more junior engineers working under the supervision of a senior engineer, and would have given due consideration to all the different factors influencing the designs. I am not convinced. I want to see the paper trail that should exist surely, that there are council meeting minutes and engineering reports from that time. The new water feature at the Green Bridge included the construction of a large island with the purpose of dividing the flow of the water. The first attempt at constructing this water feature cost £62,968. In addition, remedial work required to reinstate this water feature damaged by the first serious flood cost a further £35,618, making the total cost of the water feature £98,576. These costs are many multiples of what it would have been the cost to totally reinstate the long-proven old weir. This reinstatement would have totally prevented the 2009 flooding incident and would have greatly reduced the severity of the latest flood, which was contributed to in a major way by the Glasgow Burn overtopping. There have been suggestions made to me that there was pressure applied to the council to remove the weir to enable migratory fish to get more easily up the river to spawn. I do not know if this was the case or not, but I do know that the Dee River Fisheries Board had never reported a problem with salmon being forced to spawn in the lower river below the old weir because they were unable to progress upstream past it. In the light of this, I cannot believe that the angling pressure could have been a factor in the decision. Yet again, it would be good to know what representations for the removal of the weir were being made to the council and by which organisations or groups. Remarkably, once the weir was demolished, it was found to be an opportune moment to build a major wastewater pipe up the old river channel and across the bed of the river at its narrowest point, linking up with the existing town wastewater system. In my photograph, you can see the almost nuclear-proof concrete casing of this pipe, where it had been laid up the old riverbed, while at the time the photograph was taken, the cross-river link was only half completed. How any professional water engineer could think that laying this pipe in this position would not cause problems, I cannot imagine. The top of this cross-river concrete-covered pipe is only about 6 inches below the old water surface level. Previously, from the time the weir was built, the river at this point had always been at least 3.5 feet deep. The Green Bridge is only 26 feet wide, and after this pipe had been laid across the river, the gap from the top of the concrete-covered pipe to the overspill point was less than 4 feet. The White Bridge, about half a mile further downstream, is 42 feet wide, with at least 7 feet of space from the riverbed to the underside of the bridge. It was well known from past floods that the White Bridge could only just cope with the flood flow. I simply ask a question. How would a professional engineer designing this system believe that that full flow of river in flood could possibly pass through the restricted opening at the Green Bridge, when it was already known that the much larger White Bridge was at full capacity in such conditions? I made it clear in a previous video that the water levels in flood at the Green Bridge, when the weir was operational, never got to within 2 feet of the overspill point. Surely then this capacity restricting cross-river pipe is clearly a major factor in the causing of the flooding at this point. I believe that we must press the authorities to come up with a sensible alternative to this man-made problem in the short term, or we are certain to be subject to ever more frequent flooding emanating from this location. first building of the meal mill, dry stone wall-lined lathes were used to deliver the water in the quantities and at suitable speed to drive the machinery. There were 2 further dry stone lathes constructed to carry the water downward from the mill downstream until it reached the point where it is discharged back in the lower river. One leg of the twin lathes carried straight on from the delivery lathe, driving the mill wheel with the minimum loss of velocity and therefore power. If the miller wanted to stop the machinery for any reason, he just had to pull a lever in the mill to cause the water to be diverted into the second lathe, thus stopping the machinery to enable any work to be carried out safely. These 2 lathes originally flowed on the surface, but over time they both became subterranean as roads and buildings were built over them. The only stretch that remained in the open were behind and in front of the then newly built Catholic Church. These sections remained uncovered until the mill dam was drained and built over and the lathe ceased to flow. The 2 lathes came together at the corner of the church ground, and a stone-built culvert was constructed in stages as building development took place in its path, until the whole stretch from the church grounds to the discharge point in the lower river was reached. This totally enclosed section was certainly in place by the late 1800s and continued to function as a drain as flood prevention course until the council built up the shingle on the beach and thus blocked off any outlet to the sea. Many of the domestic houses in the area had wastewater drains flowing into both these lathes. The 2 streams draining down from the Bervie Braes also discharged into the lathes. The south end of Allardyce Street and the lower end of the Nutter Avenue were both drained into these lathes in earlier times. When the large building over the last seaward section of the culvert was used by Alexander's buses as its maintenance depot, the wash bed for cleaning the buses every night was sited directly over the culvert and drained directly into it. This culvert had to be a fairly large capacity. This culvert had to be fairly large to carry all the combined water that was regularly passing through it. When the miller, as he sometimes did, shut off the incoming water from the dam, the lathes quickly almost dried up, and this was a signal for all the local kids to get into the semi-dried up lathes and guddle or catch by hand the trout that had become resident there. I still know several older people in the town who remember this well, and some of the braver ones even ventured down the culvert to its exit point in search of fish. You couldn't exit onto the beach because all mill lathes discharge point had legally to be covered by a steel gate with the bars spaced at less than 2 inches apart to prevent salmon and sea trout trying to pass up the stream into the lathe. In both of the bad flooding incidents of recent times, this historic culvert would have helped to greatly reduce the extent and depth of flooding in the Old Town and surrounding streets, had it still been left by the council in functioning condition, without the exit to the beach being buried under many feet of shingle, while failing to provide any possible channel to let the water from this culvert reach the river or the beach. The very idea that the soakaway that was eventually built would supposedly be capable of absorbing the amount of water that this culvert was capable of carrying is plainly ridiculous. Within minutes of the flood water reaching the culvert, it filled to capacity and became stagnant, and soon filled up totally with trash and sediment, rendering this long-proven drainage system totally useless. In this photograph of the beach and the lower Carron, taken during the summer following the big 1948 flood, when the Cowie and Carron split to become 2 separate rivers flowing into the sea, You can clearly see ringed in the picture the discharge point of the culvert flowing onto the beach. At this time it was carrying more water than was flowing down the river, the miller obviously taking nearly all the Carron water available to power his mill. In the second picture of the beach in much earlier times, you can also see that there is more water flowing from this culvert than was flowing down the main river channel. Here you can see how the river mouth was not impeded in any way, allowing any flood space to spread out over the beach. You can also see from this picture that in times of any spates, the river swept straight out over the beach and spread out over a wide area of the beach as it made its way over the Single to reach the seawater level. Before Scottish Water constructed the rock barrier across the river mouth, apart from a couple of hours around high tide, there was no backup pressure on the lower Carron at all, and as high tide mark is, and always was, near the level of the base of this rock folly at the footbridge over the river mouth, the river was just absorbed into the sea. When you stood on the bridge in Allardyce Street and looked towards the sea, the spate just disappeared over the high mark and spread out over the beach as it flowed downwards to the sea. Just in exactly the same way, you can observe from the Cowie Road Bridge how the river disappears from view as soon as it passes the Rivermouth footbridge. You can see how effective this system was in my contrived photograph of the river mouth unhindered by Scottish Water's waste pipe, and the second photograph of how this pipe blocked the natural direct passage of the river seawards in reality today. The record heights of the lower Carron in recent floods are caused mainly by the effect of this stone barrier. In a recent minor flood some weeks before this last big flood, I observed that the water level below the footbridge in the river was at least approximately 5 feet above the sea level at the back of the barrier. Please, council officials, don't take us to be complete fools. We know that nature never tries to pile up water over a beach as it enters the sea. The height of floods in the lower river are also being caused to increase by the amount of encroachment into the old riverbed by man-made built-up terraces we can now observe behind the properties on the south side of Carron Street. The terrace below the chip shop now reaches almost halfway across the width of the bridge. If you narrow the historic river channel to this extent, the flood water in the river can only go higher. Similarly, upstream of the White Bridge, the bank on the south side grassy area has moved forward into the old riverbed, reducing the area available for water flow. At the end of the wall above the river in Carron Street, as it joins Carron Terrace, you will find a set of stone stairs leading down to the water. If you were to investigate the opposite bank in line with these stairs, but now some way back from the water's edge, you will find a flight of wide stone stairs. Up until the 1948 flood, these two sets of stairs were linked up with very large stepping stones, which had been used as the principal means of crossing the river on foot for centuries before the White Bridge was built. The river bank on the south side of the river started from the foot of these stairs. The grassy area followed the slope seen in the upper portion of this area, but continued down to the water's edge. You can now see where a new rock bank has been created, with the land behind it filled in to form a fairly extensive level grass area. This is at the Green Bridge on the River Carron on the 17th of July 2015. You'll see how this relatively small space is already within a few feet of the road. When you look downstream, you can see why. With all this unnecessary obstruction to the rate of flow down the river, the water simply can't accelerate fast enough to come through under the narrowest point of the river at the bridge before escaping downstream. Now we've gone down to the road bridge looking upstream, and you can see that the river is already reaching the level of the gardens and doesn't have far to go to start some form of flooding or overtopping. This never happened in the old days because with the old wide river mouth, the velocity of flow along this stretch of the river simply didn't allow the water to rise to any extent. Here we're looking downstream from the road bridge, and you can see how much of the river channel has been filled in front of the old walls. And now we're at the beach, and you can see it is virtually at low tide. I'm going to this point at the end of this wall, and from this point to where you see the flag on the other side of the river, that was the end of the river channel, and the river was now free to flow completely unhindered down the beach towards the sea, ever widening and gouging out an ever deeper channel. There's at least 4 feet of water in the river at this point at the moment, but as of old I wouldn't think there would be more than a foot of a rise. Now looking back upstream, you can again see how much of the historic river channel then on both banks of the river. And had the river been able to escape under where I'm standing at the full width of the walls, the height of the water all the way back up the river would have been about 4 feet less. Now we've come down to the present river mouth, which is only some 9.7 metres wide. And you'll, again, having to go round a sharp corner, but as soon as it's onto the beach, you can see how the river widens out, gouges out a channel, and prevents any backup at all, with absolutely no resistance at the original wide river mouth. The water simply poured out at a great velocity, and this is why for 2 centuries we had no flooding in the lower river. Where you see the turbulent water, that's where it passes over the top of the sewer pipe. But it's the restriction in width that causes the problem, not the sewer pipe. You can see there's a bit of motion on the sea at the mouth of the river, but you have to look away to the north before you see any real wave action. This corner at the Carron River mouth is always very well protected. And in the earlier in the video you'll have seen how much rock and how the depth of water is reduced, and the turbulent sea just doesn't get to this end of the bay. And that's why in the centuries previous no waves ever went up the Carron. Their waves only went up the Carron after this retaining wall in the foreground was built, and that diverted all waves to run along the face of the wall, and the only escape they had was to go up the river. Now back up at the bridge, looking along the wall up towards the road bridge, you can see how much has been filled into the river channel, reducing the capacity of flow. If you narrow any river, it has to get higher to get the same volume of water out. If it had been flowing at its full width, 16.4 metres from the south wall to the north wall, the river rise would have been only a matter of a foot. Here we're see the 21st of March looking along the beach. That's the spring equinox, and there's a bit of a swell coming onto the beach, and this shows that all the waves coming onto the beach are coming in as a regular equidistant pattern, no compression of waves causing an increase in wave height that JBA's Rivermouth report claims to happen. This is, the claims they make in the report are sheer fantasy. There is no way ever possible that waves can travel 360 metres shoreward over a rock seabed that is not more than 14 feet of water at high tide and pile up at the river mouth. All the power of the waves has been dissipated in that long travel ashore in the shallow water. This groin immediately in front of us was put there as the first attempt to stop the running waves, because the waves were coming in along the rock bank. But in effect, it doesn't do much to prevent the waves coming in, as you see. But what it does do is create a vortex behind the bank, and the seabed from behind this groin is continually being sucked out and carried away seaward. So that all the attempts over the last year that the council have made in transporting shingle from the beach at the river mouth of the River Cowie and trying to fill in this space behind this groin, in a matter of days are all removed again, and you leave the beach simply a bunch of boulders, but all the finer material and shingle has been carried away. This direction the waves are coming in today is the most open to the river mouth. Now this is a still view of the behind that groin, and you can see how the fine sand is gone, only the boulders and rough sand, looking back towards the river mouth with the rock visible outside the groin. That's the same looking across the bay towards the north end of the beach. And that's looking seaward. And you can see it's a long distance of virtually level rock all the way in. And that takes the steam out of any wave action at this end of the bay. These next pictures were taken at low water on the 29th of September, the biggest tide supposedly for a great many years. That's from behind the breakwater. That's looking towards the north in the rocks. This is out from the end of the sewerage emergency outfall. That's the pipeline you can see as we go ashore. That's looking in towards the bay, and you can see that the mouth of the River Carron is away round the corner. There's no waves can come in that direction to cause it any problem. That's at the peak of high tide at that equinox, which was supposed to be the highest tide for something like 20 years, looking up to the road bridge. And again looking further upstream, and you'll notice that the concrete wall at the base of John Briggs's property is still above water. Here we see the mouth of the river in normal times and how it silts up with the north-south drift. Now we're looking towards the north end of the beach and the river mouth. And you can see that the waves as you go further north become ever higher and potentially more threatening. At the river mouth you see the waves running in and you would assume that they might be going up the river. But this just does not happen. The waves do not have the volume or velocity to make any inroad into the river because it is so narrow and so shallow at the river mouth. The waves, as they come up the river, appear to almost halt, but the waves continue running up the beach on either side of the river mouth, and then when the wave retreats, the water pours in to the river from either side, draining off the beach with absolutely no forward momentum. And if you look at the surface of the water as the waves retreat, once it becomes a bit smoother, you'll see that there are ripples coming from either side, indicating where the flow has come from. You see the ripples here, how they're coming from each side and meeting in the middle, indicating that the water's pouring into the channel from either side. But there's absolutely no power or momentum and no volume or velocity that would be necessary to be able to enter the river system. The only waves that we have ever been able to detect over the last 5 years while filming has been taking place going up the river are the soliton waves, which are generated right at the river mouth, and they are only created for a limited period when the necessary criteria are met. Now we've gone up to the footbridge and looking along the river towards the river mouth, and you see there's absolutely no appearance of waves of disturbance going up the river at all. And this is always the case, unless we've got to have velocity coming down the river being halted by a wave. The downward velocity then piles up and suddenly reaches a point where it reverses its flow and sets off the soliton waves going back up the river. You can clearly see here how the waves on either side of the river mouth can progress further up. But then the water is pouring off the beach into the river mouth, but without any forward velocity. It doesn't have the velocity to reverse the flow in the river. It simply holds it back. And then as soon as the pressure goes off with the incoming wave, the river's pouring seaward again as normal. The illustrations in JBA's Rivermouth Rock Armour report potentially showing that the greatest wave heights and potential trouble lie on the beach in front of the Carron, whether the old Carron Rivermouth or this existing Rivermouth, is pure work of fantasy because the conditions simply don't allow it. Here we're looking at from the drone video of the severe storm, and right at the south end of the bay you'll note that there are virtually no waves. Up near the Cowie river end of the beach it's very stormy, and if you look at the end of the breakwater you'll see a large area of white water where the rebounding waves and the waves buffeting off the rocks and the armour behind the rescue centre are in conflict, but they take all the steam out of the waves, and on the shore you'll notice that there is practically no wave action going onto the beach. in the area of the river, Cowie River mouth at all. You can see virtually a line on the north side of where the rocks finish, and everywhere north of that the rock sea is piling in and going up the beach, but to the south of that line there's virtually very little motion at all, certainly not enough motion to cause waves to go up the river and enter the River Carron. And that's what all the records and reports showed happened for the last 2 centuries. That end of the beach was protected, and waves never were a problem entering the River Carron before the council actions in building the rock protection barrier for the raised walkway and starting the creation of running waves. You can see the area of intense wave at the end of the breakwater and at the end of the rock section. Now we come to the river mouth as of old. This map from around 1820 shows the river joining up with the River Cowie and going seaward. Obviously at that time there was a shingle bank in front of the combined rivers, and so no waves got to the river mouth at all. But whenever there was a spate, it was always happened that the combined rivers would break out through that shingle bank and wash it away, but within a matter of weeks at the most, the bank would reappear. Here in the 1867 map, you see the walls clearly marked, and how great an opportunity there was for the water to be allowed to flow seaward. This is looking downstream today, and you can see the infill in front of the walls at both sides of the river, reducing its width and therefore reducing its velocity. Looking upstream, and again you can see the infill on either bank up to the road bridge. When that road bridge was built, it was built so that it would be able to cope with the 100-year flood had the river mouth been left as it was. Now that the river mouth is closed off and diverted, it is at hazard of reaching water. This is a created photograph looking under the bridge at high tide, a normal high tide, and you can see that there was no resistance to flow out into the sea. But when the council decided to divert the river round the corner and along the top of the beach, that was a complete change of circumstances. And again, the rock abutments at either side of the bridge remove 20% of the available flow channel for the river getting onto the beach and flowing down the beach. But before all these interventions, the river reached the beach at the end of the wall on the left-hand side. It was several metres upstream from the first of the council-built interventions, and the water, as soon as it reached the end of the wall, was free to spread out completely unhindered and make its way seaward. Instead of that, the river is now diverted along this narrow, high-sided rock channel. And you either have a wide river mouth, which raises the water very little, or you divert the water into a restricted channel, and obviously it has to raise the water level considerably to get the same volume of water down that channel and out through a narrow seaward opening at virtually 90 degrees to the direction of flow. This is why in the last 2 major floods,
The capacity and exit onto the beach of this channel is so restricted that the water, floodwater in the river, was forced to reach the height of the decking of the footbridge. That's 2.5 metres higher than it could ever have reached in history when the full width of the river was allowed to discharge freely onto the open beach without any restriction. All the current scheme and the hugely increased heights and walls are being built to contain the water that is being forced to rise by the design of this river mouth. Here we see Wallingford's proposed barrier at the river mouth, and you'll note the arrows pointing out that this width was left to allow the river to flow, meander seawards. That would have worked perfectly because all the space was as it used to be. The water got onto the beach and got away. But more importantly, that barrier was designed to prevent the loss of shingle off Stonehaven beach and hopefully over a period of time to raise the shingle along the beach, the height of the shingle and the width of the shingle bank. And that would have prevented the sea storms reaching the promenade and damaging property, as has happened in the last couple of years. It's now more than 15 years since that barrier was proposed and accepted and was going to be built. And yet, because it wasn't built, the shingle has continued to erode off Stonehaven beach at an alarming rate. Thus our past recent storms. The idea of raising that footbridge, supposedly to let more water out, is absolutely ludicrous. Raising the footbridge isn't going to do anything, but if you release the water before it gets to the footbridge, as it always was in history, there wouldn't have been any thought about raising the footbridge. There's enough material lying in front of us on the seaward side of the river channel to build Wallingford's barrier and do some good, rather than leaving this in situ and causing all the problems that have been caused by raising water height in the river since the river was first blocked off. This was taken while the Balfour Beatty were making the Arbuthnot drain. That's why the boulders have been moved about and you see the wheel marks and grading on the beach. The sewer can be seen running across the river, the lines. This is the river mouth as the boulders were. You can see how restricted it is and how the river, they sometimes even now, if the river is very low, have to open up a track because it starts to dam the water back. Even when the full width of the river used to be in existence, ending at the walls, when the river was very low, usually in summertime periods, it would form a shingle bank across the river mouth, and the council would have to send people down to open a channel to let it away, because the stagnant water quickly began to be offensive. But if you get any flow of water at all, it very rapidly gouges out the channel and keeps it flowing. here again looking seaward, you can see how it's so protected by that rocks and the point that they stick out that it's not open to wave action at all. Now here we have a Google Earth photograph of the bridge and the restriction, and you can see how even at the present day the restriction is damming back and holding some water, and it's only as you get nearer down the beach below normal high tide mark that the river actually is flowing. But if the river had been allowed to flow straight seaward, there would have been none of these huge increases in flood heights, because, as I have repeatedly said, as soon as the water reached the containing walls upstream of the footbridge, it was free to spread out with unlimited scope to flow seaward down the beach and into the sea. The limit of flood height at that point historically had always been spring high tide level. And spring high tide level only exists for a short period over the high tide, at 12-hour intervals. Now, not many spates in the Carron flow at maximum level for 12-hour intervals. But the potential or the hazard of getting any problem backing up when the water is at spring high tide level is nothing compared to the situation you have now, where because of the restriction built on the beach below high tide, downstream from the footbridge, the water is actually being forced to back up to the deck of the footbridge, which was completely inconceivable in earlier times. The council built that channel to divert the river to prevent the waves running along the wall. It wasn't needed. Internationally, universally, the answer to that problem of running waves is a couple of short barriers built seaward which halts the running wave. That causes the wave to drop the shingle it is carrying, and very rapidly it builds up a spending beach, which removes permanently the danger of running waves. Far better to have left the open river mouth and instate Wallingford's missing barrier that would help to build up the shingle on the entire beach and prevent, in a matter of a few years' time, the possibility of seaward wave problems attacking the promenade. If the river mouth was opened up and then remodelled, you would find that a huge proportion of the cost of the new scheme would evaporate.